What happens when you die? It's a question as old as humanity itself, one that has haunted philosophers, poets, and scientists for centuries. Some seek comfort in stories of an afterlife, others in the legacy they leave behind. But what if the answer is written not in ancient texts or spiritual visions, but in the very atoms that make up your body? What if, as the legendary physicist Richard Feynman once suggested, the story of death is really a story about energy, matter, and the astonishing persistence of the universe itself? Let's begin with a simple, almost childlike observation. You are made of atoms, trillions upon trillions of them, arranged in a pattern so complex that it gives rise to your thoughts, your memories, your sense of self. These atoms are not unique to you. They have been part of other things, stars, rocks, oceans, even other people, long before they became part of you. And when you die, they do not vanish. They simply change form, moving on to become part of something else. In this sense, death is not an end, but a transformation, a passing of the atomic baton in the great relay race of existence. Feynman, with his trademark wit and clarity, once described this process in a way that is both poetic and scientifically precise. If you look at the stars and you look at the sky and you look at the universe, you see that you are part of it, he said. Your atoms were once in the stars, and when you die, they will go on to be part of something else. This is not just a comforting metaphor, it is a statement of physical law, rooted in the principles of conservation of mass and energy. Consider what happens at the moment of death. The biological processes that sustain life, breathing, circulation, metabolism, cease. The body cools, cells break down, and the intricate machinery of life grinds to a halt. But the atoms themselves remain. Carbon, oxygen, hydrogen, nitrogen, these elements do not disappear. They are released into the environment, taken up by plants, dissolved in water, carried by the wind. Over time, they become part of new living things woven into the fabric of the world in ways both visible and invisible. This is the first layer of immortality, the immortality of atoms. The very stuff that makes you is ancient, recycled, and eternal. The calcium in your bones was forged in the heart of a dying star billions of years ago. The iron in your blood once flowed through the veins of the earth itself. When you die, these atoms will scatter, but they will not be lost. They will continue their journey, perhaps to become part of a tree, a bird, or even another human being. In this sense, death is not annihilation, but redistribution, a cosmic game of musical chairs. But Feynman's insight goes deeper. It's not just the atoms that persist, but the energy they contain. According to the first law of thermodynamics, energy cannot be created or destroyed. It can only change form. The energy that powered your thoughts, your movements, your heartbeat, where does it go when you die? Some of it is released as heat, warming the air around you. Some is consumed by bacteria and other organisms, fueling the endless cycle of life and decay. Some is radiated away as light, carried off by photons into the vastness of space. In every case, the energy is conserved, transformed, but never lost. This is the second layer of immortality, the immortality of energy. The spark that animated your body does not vanish. It is simply passed on, diffused into the world, woven into the ongoing story of the universe. Feynman loved to point out that in a very real sense, we are all part of a grand, unbroken chain of energy transformations, stretching back to the dawn of time and forward into the unknown future. But what about consciousness? What about the self, the unique pattern of thoughts, memories, and experiences that make you who you are? Here, the story becomes more complex and the answers more elusive. Feynman, ever the skeptic, was wary of easy answers. He understood that consciousness is an emergent property arising from the intricate dance of atoms and energy in the brain. When the body dies, this pattern dissolves like a wave fading into the sea. The atoms remain, the energy persists, but the specific arrangement, the you that you know, ceases to exist. Yet even here, there is a kind of immortality. The information encoded in your brain, the memories you create, the actions you take, all leave traces in the world. You influence others, shape the environment, contribute to the ongoing evolution of life. In this sense, Your existence ripples outward, affecting the universe in ways both large and small. Feynman once said, "Everything is made of atoms. That is the key to understanding everything." And in understanding atoms, we come to see that nothing is ever truly lost, only changed, transformed, and carried forward. So what happens when you die? Your atoms scatter, your energy is transformed, and your influence persists. You become part of the world in new ways, your essence diffused but never destroyed. This is not the immortality promised by myth or religion, but it is a kind of immortality nonetheless, one rooted in the unbreakable laws of physics and in the enduring beauty of the universe itself. To truly appreciate the profound implications of Feynman's perspective, let's journey deeper into the world of atoms and energy. Imagine for a moment the story of a single carbon atom in your body. Perhaps it resides in your heart or your brain or the tip of your finger. This atom is unimaginably old. Long before it became part of you, it was forged in the fiery heart of a massive star billions of years ago. That star lived, burned brightly, and eventually exploded in a supernova, scattering its elements across the galaxy. Over eons, these atoms drifted through space, joined clouds of gas and dust, and eventually became part of the earth, the air, the oceans, and finally, you. When you die, this carbon atom will not simply vanish. It may be released into the atmosphere as carbon dioxide taken up by a plant during photosynthesis and become part of a leaf. An animal might eat the plant, and the atom could become part of its muscle or bone. The cycle continues endlessly with atoms moving from one form to another, from star to planet to life and back again. In this way, death is not an end, but a continuation, a seamless transition in the grand story of matter. Feynman often marveled at this interconnectedness. He saw the universe as a vast, dynamic web, with every atom linked to every other by the laws of physics. The atoms in your body, he once said, are the same atoms that make up the stars, the trees, the air, and the water. We are all connected, not just metaphorically, but literally. This realization is both humbling and exhilarating. It means that, in a very real sense, you are the universe experiencing itself in human form. But what about the energy that animates these atoms? The energy that powers your thoughts, your movements, your very life. Here, too, the story is one of transformation and continuity. The food you eat contains energy captured from the sun by plants, stored in chemical bonds. When you digest this food, your body breaks those bonds, releasing energy that fuels your cells. Every heartbeat, every breath, every thought is powered by this flow of energy moving from the sun to the earth to you and eventually back into the environment. When you die, this energy does not disappear. Some of it is released as heat, warming the air around you. Some is consumed by bacteria and other organisms, fueling the cycle of decomposition and renewal. Some is radiated away as light, carried off by photons into the vastness of space. In every case, the energy is conserved, transformed, but never lost. This is the first law of thermodynamics in action, a law as unbreakable as any in the universe. Feynman loved to illustrate this point with vivid examples. He would describe how, when a log burns in a fire, the energy stored in its chemical bonds is released as heat and light. The atoms themselves are not destroyed. They are simply rearranged, forming new molecules that drift away as smoke and ash. The same is true for you. When your body ceases to function, the energy and atoms that made you are not lost. They are simply redistributed, becoming part of the world in new and unexpected ways. This perspective can be both comforting and unsettling. On the one hand, it means that nothing is ever truly lost. The atoms and energy that make up your body will persist, woven into the fabric of the universe for all time. On the other hand, it challenges our deeply held notions of individuality and permanence. If we are nothing more than patterns of atoms and energy, what becomes of the self when those patterns dissolve? Feynman approached this question with characteristic humility and curiosity. He recognized that consciousness, the sense of being you, is an emergent property arising from the complex interactions of atoms and energy in the brain. When the body dies, this pattern dissolves, like a melody fading into silence. The atoms remain, the energy persists, but the unique arrangement that was you is gone. Yet even in this dissolution, there is a kind of immortality. The information encoded in your brain, the memories you create, the actions you take, all leave traces in the world. You influence others, shape the environment, and contribute to the ongoing evolution of life. In this sense, your existence ripples outward, affecting the universe in ways both large and small. The kindness you show, the knowledge you share, the love you give, all of these are forms of energy passed from person to person, generation to generation. Feynman understood that immortality is not about the survival of the individual, but about the persistence of influence, the continuity of matter and energy, and the endless unfolding of the universe. This view is both scientific and deeply human. It invites us to see ourselves not as isolated beings, but as part of a vast, interconnected whole. It encourages us to live with curiosity, compassion, and wonder, knowing that our actions matter, that our atoms endure, and that our energy is never truly lost. In the words of Faynman, we are a way for the universe to know itself. When you die, you do not disappear. You become part of the world in new ways, your essence diffused but never destroyed. So, what happens when you die? Your atoms scatter, your energy is transformed, and your influence persists. You become part of the ongoing story of the universe, a story that began long before you were born and will continue long after you are gone. This is not the immortality promised by myth or religion, but it is a kind of immortality nonetheless, one rooted in the unbreakable laws of physics and in the enduring beauty of the cosmos.